In this video, we're going to talk about alkenes, the fact they're used to make polymers. What do we do with those polymers in terms of waste, and what alternatives to making that waste can we place in? And we'll talk about feedstock recycling specifically and combusting polymers, especially PVC, polyvinyl chloride. Now, we've got our Earth at the moment. There's a real big push, and will be a continued push to conserve our wild spaces and to reduce our dependence on fossil fuels. So, we've seen this for the last 30, 40 years, in fact, that we have this graphic, reduce, reuse, and recycle. And we're going to go through what are the polymer parts of this in terms of your course. So, there's three types to start off with. Bioplastics, which just means a plastic that is made from a biological material, something that is renewable because you can just regrow it. And then you have biodegradable, ones that maybe even are a bioplastic but can also be broken down and go back into the earth as a non-harmful kind of waste product. And then compostable polymers, which is roughly the same thing. It can go into your compost bin and then turn into something you can place onto your flowers and such and so forth. Now, when it comes to this, there is a special one which we will talk about in another video, which is about esters and polyesters. So polyesters, in a later video, if you want to look up exactly what happens with photodegradable polymers, it's through an ester that has UV shining on it, and that UV supplies enough energy to break that ester bond. But again, that'll be in another video. And if we can start using all of these, we will reduce our use of fossil fuels, and therefore it's good for the planet. Next thing is reuse. Now, reuse basically just means what it says. We have a throwaway culture in the world. We need to change that. We reuse the materials, okay, and we fix them when they go wrong. We don't necessarily just throw away and get a new one. Now, if we look at recycle, which is where our two most important examples come in. Now, to avoid using fossil fuels and having a high dependence on fossil fuels, what we do is we recycle, and normally that's put into a recycle bin. And they sort and then chop and wash, dry and melt your plastics that you put in and other materials. They're then made into pellets, and then the pellets are then made into new materials. So when you look at a recycled bottle or something else and it says made from 50% recycled material, it's from the pellets that are made from your recycling. Now, the two specific ones for chemistry are feedstock recycling and PVC, polyvinyl chloride. And that is when you take the polymers and you recycle the polymers after you've broken them down, which is the feedstock recycling. We'll go over that in a second. And the other one is when you can recycle PVC, and you can do that by precipitating out your polymer and reusing it. But again, we'll go over that later. The first bit I want to focus on, and this is normally a 1-mark question in an exam, is just what is the advantage of combusting polymers? Well, the advantage is energy. Okay, so I've just been to a country called Norway, and in Norway there is a power plant on the edge of Tromsø, and in Tromsø basically all of the energy for the local town is produced by burning the rubbish and the polymers for it. Now, you have to have a good filtration system so you don't release lots of toxic materials into the air. And that's the first point. Polymers are plastics with that carbon backbone that can be combusted, but they can create some toxic products. Things that can be burnt include tyres, bottles, etc. Okay, but the combustion is based upon one repeating unit. So if you're going to do a balanced equation, quite easy because the combustion is based upon one repeating unit. And we're going to show you how to do it now. Okay, so we've got a similar polymer to PVC, and we'll do PVC in the next one. I'm going to show you how to do this, and then on the next slide, I want you to do PVC on your own. So let's do this. So here we have our one unit of our polymer. This is our repeating unit of our polymer. Now, there are three different products that you create. Now, the normal combustion products, so when you combust something, you create carbon dioxide and H2O because it's combusting completely. Now, the difference between this and normal complete combustion is you have an extra product here. And that extra product is the hydrogen halide of whatever is in the polymer. So you can see here there's a fluorine in the polymer. This is the hydrogen fluoride here. Okay, if this was a chlorine here, this would be HCl. If this was an iodine here, it would be HI. But you just need to understand that when you combust it, those three different products. Now we balance it like this. So you look here, you've got carbon and a carbon. So there's two carbons, and I can't change the balancing on that one repeating unit. So I only have two carbons. So I can go basically to this and just go, there you go. You've got two carbon dioxides because there's one carbon per carbon dioxide. So two carbons and therefore two carbon dioxides. We then look at the hydrogens, there is three, so I go across here and I go, look, there's two and there's three. So I don't need to balance the hydrogens because it has been done already. Then I look at the oxygens, 1, 2, 3. Okay, so it's 1, 2, 3, and we have O2 here, so that means I have to go 1, okay, and a half. Okay, so 1.5 O2, let's make that a bit longer. Okay, 1.5 O2. So you can use halves in these kind of equations. And this is how you balance a polymer based upon one repeating unit. So we're now going to move on to talk about polyvinyl chloride. That's polychloroethene. So you can stop the video now and you can try and do the combusted or the combustion reaction for polychloroethene turning into those combustion products, and try and do it without me. So stop the video and try and do it, and then I'm going to go through it. Now, remember, I'm going to focus on, we're doing these polymers and we're combusting them for energy, and we've got some toxic products, okay? And that's based upon one repeating unit. So if we then take our pen and then go, right, okay, here is our polymer. So, okay, and then we've got our polychloroethene, so there's our chloro. And then we're going to add that. Remember, this is fixed, it's one monomer, okay, or sorry, not one monomer, but one repeating unit, okay. And there we have our O2. And then from there, we're going to fully combust it, so we're going to get CO2 and H2O. And then if we look, our halide is Cl, so we're going to have hydrogen chloride. There. So we put the equation, everything is balanced off this. There are two carbons, so we're going to go 2 for our carbon dioxide. And then we've got 3 hydrogens, 1, 2, 3. Okay, and then we look here again, 1, 2, 3 oxygens. So that is 1.5 O2. So same as last time, to be honest. So if that is the case, this is only the type of balanced equation you're going to do based off a polymer. Just look at it and say, if there's a halide in there, I'm going to make the hydrogen halide and carbon dioxide and water. Now, just want to go over 2 further things to do with PVC. Okay, and remember, PVC is just made from, here we have is chloroethene, so that's what this is made from. So this is the monomer, that's a repeating unit, and that's the equation. Now, if we then go over the first bit, so polyvinyl chloride contains that chlorine which can be released and is toxic, and it can be released in terms of HCl, or in other ways might be released in terms of chlorine. That's toxic. Now I want to talk about how you could actually do something to get rid of this toxic product. So think about this. You have hydrochloric acid. What would you add to hydrochloric acid? Okay, so what would you add to hydrochloric acid to make sure you could get rid of it? Well, it's an acid, and therefore you would add a base. And you would add a base to neutralize. Okay, so that'll be one way of getting rid of your toxic byproduct. But if it's just chlorine and you have an equation which is chlorine, simply that chlorine is toxic, and that's all you need to say. Now, another way of recycling or using the polymer is to dissolve it, and then you precipitate out the recycled material. And this avoids this problem. You don't have the HCl produced or chlorine produced in any way. So you can dissolve it, precipitate it out. That means you can then reuse the PVC, and that's what they're doing a lot nowadays, is dissolving the polymer, precipitating it out, and then you've got this nice plastic you can reuse again. Our last example of recycling polymers is taking the example of polyethylene. Now you can do something called organic feedstock recycling. So what that means is it takes the polymer and turns it back into its monomers. So I wanted to show you how you can turn it back into your monomers. So first of all, they're the different units. You can see this is polyethylene, hopefully, because you can see each unit is 2 carbons long. So 2 carbons and 2 carbons and 2 carbons. So you can see this is made from a monomer, and the monomer would be ethene. Now what we do in feedstock recycling is we break the bonds between the different repeating units and turn them back into the alkenes, and then the alkenes can be reused to make more polymers. So let's do that. So we've turned it into the repeating units. From the repeating units, I'm going to put the double bond back in, and here you have 4 ethenes that we use to make that section of polymer, and they can be reused to make new polymers.